Hello class, today we're going over our multiplying and dividing integers readiness guide. First thing we need to be able to do is to model the multiplication or division of integers. And we'll start by just looking at the multiplication of integers. We need to be able to write a sentence explaining what our multiplication means, model the multiplication with tiles, and explain how that model shows the product. So we know that the first number in our integer multiplication is going to tell us the number of groups. So we're going to say that this is 4 groups. Our multiply sign means of, and our second integer tells us how many and what type of tile. So we're going to say there are 3, and they are negative tiles. So as far as drawing that goes, we're going to draw our 4 groups. Oops. And inside each group, we're going to draw 3 negative tiles. Our product is going to be the total number of negative tiles. So we'd say all together there are 12 negative tiles. And that tells us our product is negative 12. So this first line here is our part A. Write a sentence in words for what our multiplication means. Obviously we got our tile model, and then we've got our product. So that works if we have a positive number of groups like in that first one. We can do a similar thing in the bottom right one as well. We can say that we have 3 groups. Our multiply sign means of, and of course we've got 2 positive tiles. And so let's go ahead and make our 3 groups. 1, 2, 3. And we need 2 positive tiles in each one, so 2 shaded tiles. And of course, what's our product? We'd say all together there are 6 positive tiles. And so our product is positive 6. For our other problems, what makes them tricky is that we can't ever have a negative number of groups. So we can't say that we have negative 5 groups. We can't say we have negative 2 amount of groups. So instead we're going to use our little trick from class, which is that a negative integer can be written as 0 take away the positive integer. So we're going to say that this is 0 take away positive 5 times negative 3. So how do we model 0? Well, 0 is modeled with 0 pairs. And so we're going to start by drawing 5 groups of 3 0 pairs. So there's 1, 2, 3. There's 1 group of 3 0 pairs. 2 groups of 3 0 pairs. 3 groups of 3 0 pairs. 4 groups. And 5 groups. So far we've modeled 0. Now we need to take away 5 groups of 3 negatives. So there's a group of 3 negatives, we're going to take them away. There's a group of 3 negatives, we're going to take them away. Another group of 3 negatives, another group of 3 negatives, another group of 3 negatives. Now remember, we draw this take away symbol to kind of show our work. But if we wanted to, we could redraw what is left. We'll obviously have just our positive tiles after that. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positive tiles remain. And of course, that's why our product here is positive 15. As far as our sentence in words explaining what our multiplication means, we're going to say start with 0 and take away 5 groups of 3 negative tiles. And of course, then we'd have 15 positive tiles remaining. We could do the same thing for the next one. We're going to rewrite it as 0 take away positive 2 times positive 5. That means start with 0 and take away 2 groups of 5 positive tiles. And so we're going to start by drawing 2 groups of 5 0 pairs. 1, 2, 3, 4, 5 0 pairs is one group. 1, 2, 3, 4, 5 0 pairs is the second group. So that's our 0 so far. We need to take away from that 2 groups of 5 positives. So take those ones away. It's one group. Second group, we'd be left with 10 negatives. And so we'd say our product is negative 10. If we are given a model, we can go ahead and write a multiplication equation. In this case, we have 2 groups, 1 group, 2 groups. So we'd say our first integer is positive 2. And inside each of those groups are 3 negative tiles. So positive 2 times negative 3. Now, if it's an equation, we need an equal sign. So what product would this equal? Well, altogether, there are 6 negative tiles, so negative 6. In this case, we actually have it written out in words. So we've got a group of negative 5, another group of negative 5, and another group of negative 5. So we're going to say that we have 3 groups of negative 5. To be an equation, we need an equal sign, and positive 3 times negative 5 is negative 15. Part C, we have 0 pairs, so we know that our first integer is going to be negative. We have 1, 2, 3, 4 groups, so negative 4 is our first integer, and we're taking away groups of 2 negative tiles each. We're taking away the negative ones. And again, to be an equation, we need an equal sign, so this will equal positive 8. As far as a pattern of multiples go, you could look back at lesson number 3, I believe. And we're going to go ahead and start with easier multiples than negative 4. So let's maybe start with 2 times negative 3. And that would give us negative 6. We decrease our multiplier by 1. What happens to our product? Well, we're still going to multiply by negative 3. Negative 3. Decrease that by 1. 0 times anything is 0. Decrease that by 1. And so on and so forth. So you can see that we are increasing by 3 for every multiple that we go up. So if we continue going in that pattern, we're going to decrease by 1 again to negative 2. And we're going to increase by 3. We're going to increase by 3. And I'll just keep going here off the page. Decrease by 1. Increase by 3. So we could say that, in fact, our positive 4 times negative 3 is, in fact, equal to positive 12. These middle ones here, we wouldn't even necessarily need to keep saying we're multiplying by negative 3. We can just use our first 2 to establish the pattern, and then continue the pattern all the way down until we're multiplying by negative 4 at the bottom there. All right, next thing is modeling division. Remember division, the first number is what you start with. And so in part A, we're going to start by modeling 10 negative tiles. There's 10 negative tiles. Now our division sign means split up, and since we can't split this up into negative 2 groups, I'm going to split this up into groups of 2 negative tiles. So here's 2 negative tiles, they can be a group. Here's another 2 negative tiles, they can be a group. Here's another 2 negative tiles, they can be a group. Here's another 2 negative tiles, they can be a group. And another 2 can be a final group. If we count up how many groups we have 1, 2, 3, 4, 5 groups. So we'd say our quotient here is positive 5. Same type of thing in part B. We're going to start by modeling 12 tiles. And they need to be negative. And we need to split those up into, well, we could say groups of 3 positive. We don't have 3 positive anywhere in this drawing. So instead, we're going to split this up into 3 groups. And so here's 1 group, here's 2 groups, here's 3 groups. And our quotient is therefore negative 4. There are 4 negative tiles in each group. So with all that tile work under our belts, we were able to establish some signs. Our rule is that if we have the same sign multiplied or divided, then the sign of the product is going to be positive. Same would apply if we have the same sign but negative. Negative. And again, it applies for both multiplication and division. Still going to be positive. If we have different signs, so one of them positive and one of them negative, our product or quotient is negative. And again, the order doesn't matter there. As long as they are different signs, the product or quotient is negative. Again, these other ones apply to division as well. Part 6. From lesson 6, we went through multiplying or dividing a larger number of negative factors. The key here is the negative part. We can have as many positive integers as we want multiplied or divided with each other, and the answer will be positive. Negative, though, could be negative or positive depending on how many we have. And the key here to producing a negative product is we'll need an odd amount of negative factors. Think, for example, negative 1 times negative 1 times negative 1. Our first two same signs will produce positive 1. But then multiplying by the last one will have different signs and therefore be negative. Right, so applying our rules, we know if we have the same sign, our answer will be positive. Different signs, our answer will be negative. Otherwise, we just multiply or divide the numbers as usual. So 3 times 6 is 18. Positive times negative is negative. 27 divided by 9 is 3. Positive divided by negative is negative. 2 times 16 is 32. Negative times negative is positive, same signs. 3 times 8 is 24. Positive times positive is positive, same signs. 100 divided by 25 is 4. Negative divided by negative is positive. And 44 times 10 is 440. And positive times positive is positive. Those ones go quite quick with your basic times table, and you just have to adjust the sign depending on were they the same or different. Finish up these last two questions. We want to consider the following integers. We want to know which two integers will produce the greatest product. The largest number is going to be positive, and it's going to be a big number. And product means multiplication, of course. So if we want it to be positive, we need our integers to have the same signs. And we want the biggest numbers that have the same sign. So I could either use positive 8 and positive 12, or I could use negative 10 and negative 11 for my biggest product. So if I'm not sure, 10 times 11 is 110. 8 times 12 is 96. So obviously the bigger one of those is 110. So we'll say negative 10 times negative 11 will give us the biggest product. If we want the lowest product, we need it to be negative, but we need it to be a big number. So we want the biggest number with different signs. So in this case, I'm going to use negative 11 and positive 12. Those are my biggest factors that have different signs to each other. Lastly, write 4 integer calculations that could result in products or quotients of minus 8. So obviously a ton of these, so we could do 1 times negative 8. That would give us minus 8. Do negative 1 times positive 8. That would give us -8. We're going to do 2 times -4, or -2 times +4. Those are kind of your obvious ones. We could also do some divisions. So we could do something like 16 divided by -2. Or we could do -16 divided by +2. That would give us 8. And so on and so forth. There would be lots of them. The key is that to make it negative, we need to obviously have different signs in our two factors to be able to make that negative. So that is working through the integers, multiplying and dividing readiness guide. Hope that helped.